Hi, my name is Sanam. For my assignment, I thought, what better way to talk about food physics than talk about water? As we all know, water plays an important role in food. Many foods such as meat, poultry, seafood, fruits, and vegetables are composed of 75% water. So, water is the most abundant component in many fresh foods. A very important aspect of water is water activity. Now, what do we mean by water activity? When water is placed in a closed container, water molecules with enough energy will try to escape into the headspace in the form of vapor. Those are in constant random motion and exert a pressure on the top and the sides of the container. The more water molecules there are, the faster they move and the higher the water vapor pressure will be. Water molecules are in a dynamic equilibrium with water. Overall pressure in the container is always constant. Basically, the water activity of a food is the ratio of partial vapor pressure of water above food to the vapor pressure of pure water at a constant pressure and temperature. The same concept applies to food. Some of the water molecules in the food can't escape into the headspace as they interact with components of food. Hence, the equation gives us water activity. Moisture content and water activity aren't the same, but at least they relate to each other. Foods with higher moisture content tend to have a higher water activity. If we plot moisture content versus water activity, we can visualize this relationship. This type of graph is called an isotherm, which we often divide into three parts that show three different water mobility and food properties. In region 1, moisture content and water activity are both low. Water molecules are tightly held by the food and have a limited mobility. In region 2, moisture content is still relatively low, but water activity increases rapidly with a small increase in moisture. Water molecules interact with the food but have some mobility. In region 3, both moisture content and water activity are high, and the water molecules have a high mobility. In addition to differences in moisture contents of foods, in each of these regions have a different textural property. Food in region 1 tends to have a dry or crisp texture. Food in region 2 tends to have a chewy or moist texture, and food in region 3 tends to have a soft and juicy texture. Food stability also differs between water activity regions. We can gain insight into differences in food stability by using the isotherm as a template for a map of sorts. Many reactions and microorganisms that affect the quality and stability of foods have water activity dependent reaction rates, so by plotting the reaction rates of growth rates from microorganism against the water activity, we can predict which factors will affect food stability based on its water activity. The number of factors that can reduce food stability increases with the water activity. We can see that in region 1, lipid oxidation is the main stability concern, and most other factors like microbial growth, non-enzymatic browning, enzymatic growth, and enzyme activity can occur to some extent, but microbial growth is still not a big concern. However, in region 3, foods are susceptible to all factors. Foods in region 1 have high stability or longer shelf life. Food in region 2 have an intermediate stability or an intermediate shelf life. Foods in region 3 have low stability or short shelf life. However, foods in region 3 can undergo processes like canning and pasteurization that improve their stability and give them a longer shelf life. Examples of food in region 1 are cereal, chips, and crackers. Foods in region 2 include chewy granola bars, raisins, and fruit rolls. Food examples in 3 include fresh fruits, vegetables, milk, and meat. Water is a major component of most foods. It influences the taste, appearance, and spoilage of food products. There are two types, water content and water activity. Water content, also known as the moisture content, is determined by drying the food product. This is to determine the moisture loss. We need to know this for labeling, packaging, and storage, whereas water activity helps us determine the shelf life of the food product. For example, a fresh fruit, such as an apple, will have a higher water activity than jam, although both have a high water content. Why? Water in jam is bound structurally and chemically and not freely available. The more free water there is in a food product, the better the environment for microorganisms to grow. Water activity is based on a scale from 0 to 1, with pure water having a water activity of 1. The higher the water activity, the more it supports the growth of most microorganisms and bacteria. With a medium water activity, it will support growth of yeast and mold. At low water activity, the food is considered shelf stable. Water activity is used as a measure of shelf stability. Thank you for watching.